think it's like Monday or something like that.
You start, you don't actually cut, you curve?
No, like I do like cutting drills.
Sweet.
What homework do you have to turn in for this section?
That's all the APs you said.
And all the APs for sure, but I would
Okay.
rather do some of the other problems too, make sure you know how to do
Nice
it.
to find out.
There's not a lot of problems to churn in here, but, I mean, make sure you're doing the other homework so you know when you get to the test.
I should probably print that out.
This test is a little, I don't know,
This is hard. Oh my
I wouldn't say
God.
hard, it's just, some of it is easy and some of it's hard, it's just kind of a different test, I always say.
There's so many ways to interpret this.
Yeah, and that's the problem with this chapter. When we get into the next chapter, is just integrals, just do integrals, it's not as bad. This one's a little bit different. Okay, let's just talk about this real quick here. Using integrals to find work area works extremely well as long as you can find the antiderivative. If you can't, then we use rectangles and draw pictures out, right? Otherwise, it's kind of hard to do. Sometimes the function is too complicated to find the antiderivatives, and other times we don't even have a function, but only the measurements taken from real life. And you'll see some of those coming up. What we need is an efficient method to estimate area when we cannot find the antiderivative. And we kind of did have some methods. We had the LRAM, we had the RRAM, we had the MRAM, and all that kind of thing, right? And we used those. We had the calculator that did it. And the problem with all those methods is there's error. You know, and there's still error at this one. You know, like on here, we could do the antiderivative of this one. Like, say y equals 1/8 x squared from 0 to 4. Here's the curve. We're trying to find the area underneath the curve. Now let's just review some of our topics. We look at this function, the area above is always above the x-axis, right? So my area is always going to be positive, so which is good. So if I just took the integral of this, integral means 0 to 4, 1/8 x squared plus 1. I had one of the exponent of both of these. Plug in my numbers. Everybody remember doing this, right? And I get an answer of 6 2/3. That's the exact answer. Now, how else could you do it? You could split it up into intervals. You know, I could go, if I use my LRAM here, I could go with left RAM here and draw left rectangles of 1 wide. And what's the problem with that?
There's gaps.
Yeah, there's going to be shortage, right? I use my RRAM, what's going to happen there? It's going to be
Too big.
too big. And MRAM's going to be closer, but it's not exact. You know? And so all these methods are nice, but there is always an error. This is the best if we know the answer, and that's what they're talking about here. The left-hand rectangular, 5.75. We had 6 2/3. Right RAM was a little bit too high, 7.75. And so, and look, they talk about error. Averaging the two, we have a 1.25% error, 6.75. That's actually, averaging the two isn't too bad when we think about it. 6.66 is the actual answer. Isn't that too bad at going through it? It's a good estimate. Now, what we're going to talk about is the trapezoid rule. You know, and I don't know if they have it on the next slide here. If I deleted the slide. Okay, so we're going to talk about the trapezoid. Let's go back a second here. Okay. And you notice they have a 1/2 in front of them. We'll talk about the rule in a second here. They got 1/2, 1 and 9/8. Okay. And then the next one is 1/2 and 9/8 and 3/2. Well, 3/2 and 17/8. And now where do they get all these values? Think about trapezoid rule. How do you find area with trapezoid?
1/2
Base
sum of the
base one plus
Okay.
base two.
1/2 sum of the bases times height, correct? Now if you look at this trapezoid here, what's my height? 1. Always 1, right? You don't see the 1 up here. I could put the 1 right afterwards, all of them. They could make a difference, is it? They got the 1/2 always in front. Now if I look at my bases here, you started off with 1 here, right? Now if I took 1, and I can't remember the formula, it was 1/8 x squared plus 1, I believe it was, correct? If I plug in 1 into this equation, I'm going to get 9/8. 1, 9/8. That's my two bases. Make sense? Over here, 9/8, 3/2. My two bases. 3/2, 17/8. 17/8, 3. What am I doing? I'm just finding areas of trapezoids, right? Now, if you think of all the methods here, which one's going to be the best method? Probably this. If you look at the error here, is there a lot of error? No, it's pretty close. I mean, it's not a bad estimation as you go through. You know, working it out, what they did is they took all the halves out, added all the values, and they get to 6 and 7.75. And we know that from a little previous slide is 1.25% error, which is not too far off.
So it gives you the same as MRAM?
Pretty close, yeah. No, not the same as MRAM, but a
Well,
little
in
bit.
this case.
Little. Now, in this case, it did, yes. Now, notice what I'm going to go back here. What do you notice on this one? This is actually, I like how they did this. Notice when they did this trapezoid rule, they went 1 plus 9/8, right? And then 9/8 and 3/2, and 7/18, 17/8, and 3. I didn't copy wrote this. Because when they wrote it together, you'll notice it's the first one, y coordinate, right? 2 of the second y coordinate, 2 of the third, 2 of the fourth, and then 1 of the left. Now, if you look at the formula, first y coordinate, 2 of the second one, 2 of the third one, 2 of the ones in between until you get to the last one, and then there's 1 of the last one. Do you understand where they get the formula from? As they break it down, it's always the 2 bases because they repeat each other's base. H over 2, H is the width of the subintervals. So it's like 1 over 2, but as we go through.
Yeah.
And we'll talk about that a little bit better too, what H is. This gives us a better approximation than either the left or right. It's approximately M, but it's left or right. Midpoint, the midpoint here is 6.625. It's not too bad. The midpoint rule in this trapezoid rule is a little bit off than that. Midpoint's probably a little bit better. Because what happens at the midpoint is, if you think about the midpoint, you got this area and you got those areas. So we're going to kind of offset each other. That's the MRAM, you know. And like this one and this one will offset. So there's not going to be a lot of error. So you think about, we had 6 2/3, 6.666. This is 6.625. There's not a lot of error between the MRAM and the actual value.
What's gonna be closer usually, MRAM or trapezoid?
MRAM probably going to be closest.
Is it just easier to do the trapezoid rule?
Sometimes it's easier to do the trapezoid rule because of the fact that you need to figure out the midpoint. Here you go, if you have all your y coordinates, it's not hard to do them. MRAM is a little basis where, and if your curve is a little bit different, it could draw a circle too. So, I like how they did this. Ooh, I don't know why I did this. Yeah. Trapezoid rule, this is somebody else's, not mine. Trapezoid rule has a 1.2% error. Midpoint, this. Notice that the trapezoid rule gives us an answer that has twice as much error as the midpoint rule, but in the opposite direction. So we're too high instead of too low. And so it says here, if we use a weighted average, and what they said here is 2 times 6.2, 2 times the midpoint plus the trapezoid rule divided by 3, we get the exact answer. I have no clue.
How
That.
do you divide it?
There's 3 values. 2 of them here. One is like picking the average.
Did we ever use that?
I don't think we're going to use that much, but just kind of neat how that works. It works out the right same way. Works out to the exact answer. So, they wrote the rule down. The weighted approximations, I'm not going to get into all the weighted parts here and stuff like that, 2 midpoints, trapezoids. So I'm going to try to get into a problem here real quick because he has to leave. Let's go to the book. Let's try a problem. The trapezoid. Section 5. Let's just look at number 1 to start with. Actually, 1 through 8. Let's do number 3. And I did want to point out one thing. If you go back 2 pages here, page 290, they have, on page 290, they do have the trapezoid rule listed there. And I want you to look at the rule that we talked about, right? T equals 1 h over 2, this, right? One thing they didn't have on the screen is the one thing I want to point out. H is b minus a divided by a. B and a are the intervals which are integrated, and n is how many intervals of some equal length are in common. So h is b minus a or n. So if I was doing number 3 now, if I read the directions on number 3, it says here, use the trapezoid rule if n equals 4 to approximate the value of the integral. So what we're doing here is 0 to 2. So we're doing the integral from 0 to 2 of x cubed dx. Okay? So if I graph this out, just for reference, my graph is gonna look like this, 1, 2, something like that. Correct? And the hardest thing on this trapezoid rule might be is to find the y coordinates. And let's just write this out real quickly. How many intervals we want? 4 intervals, okay. So we got 4 intervals here. So we're gonna have 0.5, 1, 1.5, 2, and we're gonna have 0. That's where our values are. Wait, do you think? 4 intervals. What is my length? Now, if I think about h, you think of this formula, the formula goes like this. The trapezoid rule says h over 2, and I'm just going to write it out times y0 plus 2y1 plus 2y2 plus 2y3, and for this one plus y4. And that's going to be the rule on this one. Okay, am I agree? And the reason I went to 5 intervals, I have 5 values on the bottom. A little bit different. Now, a couple things. H over 2, I just said a second ago, H is B minus A over N. Okay? Where are we going from? 0 to 2. So 2 minus 0 over N. N is the number of intervals we want, is 4, so it's 1/2, which is the length of each interval. It's another way to think about it. It's the length of each interval.
And there's over 2?
What?
Then,
So 2 over 4 is 1/2.
But then that is over 2?
Yeah, that's over 2 though. This is going to be over 2. So you got h is 1/2, so you're going to have 1/2 over 2 times. And then I'm just going to write it out here. It's going to start like this, and I want you to figure it out. It's going to be f of 0 plus 2 of f of 0.5 plus 2 of f of 1 plus 2 of f of 1.5 plus f of 2. You know, follow me? I'm just plugging in these numbers down here. 0.5, 1, 1.5, and then 2 and 8. So now what you need to do is, I need to go find these f of 0. F of 0 is not hard to do. 0 is what? 0. So you got, I'm going to put it here 1/4 times 0 plus 2 times f of 0.5. Well, f of 0.5. 0.25. 0.125? 0.125, so 0.125. Plus f of 1 is going to be 1, right? Plus f of 1.5.
3.375.
3.375. Plus f of 2 is going to be 8. So I just plugged into my values. Plugged in these values in for x cubed, correct? Got my values up. I'm a little fancy there. So now I'm going to add all these up. Then. So I got 1/4. I'm just going to go 0 plus 0.25 plus 2 plus 7.5 plus 8. I'm just multiplying out there. So I got 1/4 of 17.75. And I don't know what I had it right.
$3.375.
3?
It's 3.375, not 3.75.
3.375. Oh, okay.
So then it would end up
Okay,
being 3.67, 3.75.
That's what would be.
3.375 would be 6.75?
Yeah.
Okay, 14. So that'd be 7, 15, 17? Okay, so 4.25? So with the trapezoid rule, we found the area to form. Okay? Now if you're looking at this, it says on the problem, it says to use the concavity function to predict whether the function is approximate, is an overestimate, underestimate, find the inverse exact value of the answer. Okay, so if I was doing the trapezoid rule on this one, I'm just going to over-exaggerate. If I did trapezoid rule, what do you think is going to be This is gonna be over estimate, so the value's probably gonna be too much, right? If it's concave up, it's gonna be too much, if it's concave down, it's gonna be too little. Okay, exact answer? Integral from 0 to 2 of x cubed dx. Okay? Have fun time. Add 1, divide by it, you're gonna get
1/4.
1/4 x to the 4th from 0 to 2. Right? And if we do that, plugging in 2 into this equation is 16, a fourth of that is 4, so we're gonna have 4 minus 0, which is 4. So how much extra do we have? 0.25. Not a lot, but a little bit, right? That makes sense. So that's the x cubed. Now let's try another one. Let's try, you do number 4. Do number 4. And I don't know about you, but for me, it's better for me to graph them. You don't have to, but if I'm looking at this function, 1 over x from 1 to 2, I think it is, right? From 1 to 2, and I'm gonna get 1, it's gonna be 1, and here's 1/2, so I'm just looking at a graph. Something like that, right? So I like to graph them out just to see what the graph looks like.
the last
Oh.
Like,
Anything else,
I look
right?
at there like, what?
Yeah, I'm trying to do it with my hand. Did I get 1/8? 1/8, remember, this b minus a over 2, or over 4, right? But then you have to divide that by 2 again to get the 1/8. So 1/8 there, and what does this add up to inside?
5.5769.
619. Well, so you take an eighth of that. So an eighth of that would be
0.697.
6.975. Now how close? Now this is one of the integrals that people have trouble with. If I'm going from 1 to 2 of 1 over x, how do I do the integral?
Move it to x to the negative.
X to the negative 1. Okay, so 1 over 2. If I do this x to the negative 1, add 1 to the exponent, what do I get?
0.
Divide by 0. Can't do it.
Undefined.
No way you
Thing.
You're going reverse.
Now, I don't show the answer. I'll just think about it. Don't look at your sheets. What has a derivative of 1 over x? Think about it. What?
E.
Think about what has a derivative of x? Think. It's not e. What is derivative of 1 over
That's
Natural
what I was
log.
thinking.
Natural log has a derivative of 1 over x. So the integral of 1 over x actually is, I'm going to cut this off, is the natural log of x. And so then you're going to plug that in from 2 to 1.
Maybe over
It should be over s, I believe so. So this is really natural log of 2 minus the natural log of 1, which is the natural log of 1 is 0. So that's 0. So this ends up being the natural log of 2, which is, I have no
0.693147.
clue, 147. Okay. So was it far off?
Not too bad.
Not too bad. It's not very far off. But as you look at it, but notice, and this is kind of like, it kind of leads in a little bit into the next chapter when you start thinking about what is a derivative. If you can't think of a derivative, you can't think of what is the antiderivative, you think about what would the derivative be. Here, a lot of you start thinking into it, like, what has the derivative of 1 over x? Took a little while, but we got there. As we go through. Now that's trapezoid rule. Any problem on the trapezoid? Now the other rule we talked about is Simpson's rule. It's another way. Kind of the same thing, making shapes, splitting up the area.
What's a Simpson?
Does it involve the
Simpson, there's a guy, some guy who thought about, said, let's make a better rule that gets more exact yet.
I like
So is this
It's
like,
still,
like
yeah,
the
yeah,
M-RAM? Does this get closer than that?
This would, I wouldn't say that MRAD is probably going to be one of your closest methods. It's probably going to get closer than trapezoid rule, the Simpson's rule. But it's not probably going to be the simple. We'll look at different options. Like here, actually, maybe this is better than the Simpsons rule. So you look at the Simpsons rule here. How close did they get on the answer?
Exactly.
They gave exact. So Simpsons is a pretty good estimate as you go through. Not a lot of difference. H again is the sum integral. N has to be even, but kind of the same setup. B minus a over 2. B minus a over n is your value still. So if you said from like the last problem we went from 1 to 2, right? It still would be like the 1/4, but now instead of dividing by 2 again, we're going to divide by 3. Now you notice on here is a little different here. Notice it doesn't go 2 and 1 and all that kind of stuff. It's kind of set the same way. First value is this first value, y value. Not much different. But then it goes 4, 2, 4, 2, 4, 2, 4, 2, 4, and then all that stuff. Okay? So it's not a lot different than the trapezoid rule, but you have to remember to go alternating 4, 2, 4, 2.
What is the n minus 2?
Whereas the n minus 2 means the previous term. Like here's the nth term.
Oh,
If I go one before that, it'd be the n minus 1 term, and this would be the n minus 2 term, and so on. So it's not a lot different than the rule. Now we're intervals. You notice on here we got 1, 2, 3, 4, 5 values, right? When the last problem we had 4 intervals, we always had 5 values, correct? It says up here we have n must be even, and the number of intervals have to be even. So it should be 4 intervals, or 6 intervals, or 8 intervals. Okay?
So like 4 and 2 is
Yeah, four intervals is even, so that's why we want it. 4 intervals is even. If this is an even number, and it's an even number, how many values are we going to have out here? It's always one more than that.
So that still works though.
Yeah, so then you think about it, why do you want one more than that? We want this to balance off. First value, last value, we always want it to go 4, 2, 4. If it's another extra value, then it's going to be another 2, 4.
So you
Oh,
want
is it?
to start with 4 and end with 4.
You want the even value as you go through here. Okay, for the Simpsons rule. And it's a pretty good estimate. Simpsons is very good with it. Simpsons rule can also be interpreted in fitting parabolas to sections of the curve. Simpsons rule usually gives a very good approximation within a relatively few subintervals. And it's usually, especially so we have no equation and the data points are determined experimentally. So in other words, if we just have a picture, and said, okay, here's a picture of a graph, I have no clue what the equation is, but I know my heights as I go along, Simpsons is going to be a very good estimate.
Wait, which comes first, 2 or 4?
4 comes first.
And also, hello.
So, let's look at Simpsons rule now. Let's go, let's actually go with this one we just did here. Number 4, we just did 1 over x, correct? We did the intervals and everything. Let's just do the same problem over Simpsons rule. So if we did the intervals, it ain't going to change much. We know our values. So if I was setting it up here, b minus a over n, so I got 1/4. So the number in front of the Simpsons rule is going to be 1/12, correct? Because we divide by 3. If you remember that. And then I'm just going to write this out. Just here, it's going to be f of 0. You should have the picture in front of you. Plus 4 f of, actually, I know f of 0, f of 1, right? F of 1.25. Plus 2 of f of 1.5, plus 4 of 1.75 f, plus f of 2. So I went from the first value, last value, and then I went 4, 2, 4, correct? As I go through here. So I have 112. Now, f of 1, and 1, I believe. Plus 9, is that
28.
5 fours, 4 fifths, times 4.
Oh, I just multiplied through it already.
8.3.
And if I divide that out, I get
6,
69325. If we look at that, when I got here, when I did the Simpsons rule, I got 0.69325. Go back a page here, a couple pages. Same problem. The one where we got 0.6975, right? Here we got 0.69314.
Wait, I actually got exactly that line. Simpsons rule.
No, no, I don't.
It might have been close, whatever. But either one, actually, it's
I
three
didn't
decimals.
round my fractions though, so.
Yeah, it depends on how you do your fraction, but with this 0.69314 and 35, depending on how you round it, Simpsons pretty good. Getting very, very close to the exact answer that we have when we do it out. Again, it's going to be easier when we do these problems. It is easier to do the integral. Why? Drawing these triangles, using Simpsons rules, trapezoid rules. we use, like, when I say shape, I'm looking at like number 8. If you look at number 8, I'm not gonna do it right now, but if you look at number 8, we don't have an equation, we have a pond. You know, if you think about it, if I wanted to find the area of this, you know, you don't have an equation to work with, you know, and so you're gonna have to work around that a little bit. Then you use the shape and go from there. Or, if you want to find like the volume of a swimming pool, we don't have the, we kind of have an equation, like a number 7. It says it's 30 times this. County volume, you got a volume here, you get the heights at different levels. Well, figure out where it is.
So how do you do like 8? How can you use it?
So you got your Y values here, you kind of think about 0, 800.
Oh, so you don't need your X.
You don't need your X. You get your intervals, it looks like to be about 250 each one or something like that.
200. It says vertical spacing.
Vertical spacing is 200. So then you can kind of look around that as you go. You can go, your trapezoid, you know, is 200 is your B minus 80. And so you divide it out. Work it out from there. There's not a lot of problems on this section. There's some, you still got the error to do here. And the error is on page 294, on the top of page 294. It talks about the error, trapezoid rule, and the error. The Simpsons rule, we will deal with that on Friday. Okay. This kind of looks like a nasty form of height 4, H4, M to the 4, and all that kind of stuff. Max of the 4th derivative, and all that kind of thing. So we will talk about that. Simpsons trapezoid, not bad. This chapter is not too bad. It's going to take a little time. The hardest thing about this chapter is this. They used to do a problem pretty quick. The last chapter was rivets. These problems, you get finding areas and stuff, it takes a little time to make a problem.
Plus we've been gone so much.
No, math contest March 13th. Anybody not want to go?
What day is it?
That's Wednesday.
Are we stopping to eat somewhere?
You usually go to the mall.
Yes, you can.
But anybody not want to go? We have 10 seniors here.
We should adopt a pebble. Yeah, we'll bring home a puppy. Yep. We're gonna go pet slaughter.
So yeah, we got 10 seniors, so I don't know how I'm going to work it yet. I might have to call up the university to see if we can get 2 alternates. So,
Being just for the alternates if you can.
you know, so. I usually do 2 alternates, and then whoever doesn't show up that morning.
Are we at 7 or what?
Gus is the first alternate, I'm second.
Nice, so I always take the senior high division, because then we're done by 11:30, 12 o'clock after sit awards. This year we're going to the awards, because we're going to win the award.
Ah, yeah.
So, and then we're done with awards, and then we go to the mall.
Only Asian.
No, it's
so unfair.
we
No
actually
pressure
get-
every year.
We actually
So
get to go to
sick of
the
it.
mall though when it's open, because
Yeah.
like the younger
When we
kids
were
have to walk
younger,
around.
We just walk around when it's closed. It was the stupidest thing. Talk to mad people. It was closed.
There's other schools there.
It was closed.
Doesn't
It
it
was
not
open
open
for
like
like
10?
it was open
Yeah.
for like an hour while we were there.
So you get to go to the mall for like 2
And all the people look at us like,
Let's see,
why
how
aren't they
long-
in school right now?
Yeah, it was like Aren't for all you guys
You know,
yeah.
creepy people.
So.
Yeah,
There's just tons of mad people walking around.